Hi, this is Carl Meinke from Anomaly. Thanks for dropping by. Today I'm going to talk to you about our new ROBOTest autonomous testing tool. ROBOTest is a new approach to autonomous software testing based on AI and machine learning. Since autonomous testing is a radically new category of test tool, I'd like to tell you a bit about ROBOTest, what it does, how it works, and why you can trust it. So let's begin. Let's start by talking a little bit about autonomous AI systems. We've all heard of chessbots that are powered by AI. They've been around a long time, and originally they were not very powerful. Probably, back then, most people believed they would never beat a grandmaster. However, as we all know, AI technology has advanced very rapidly, so today, even a chess grandmaster can lose to a chessbot. Why am I talking about chess here? Well, playing chess and testing software are both examples of what we often call search problems. In chess, the boss must search for a winning move, while in software testing, the bot must search for a bug. In chess, the chess bot plays against a human, or another bot. In testing, the test bot plays against a developer who has unintentionally hidden a bug in some code. The testbot has to find all the bugs. How could a testbot do that? There might be lots of ways. I'm going to show you how ROBOTest finds bugs in the next few slides. ROBOTest doesn't only get its power from AI. The tool leverages other technologies too, and these are pretty important to know about. Firstly, ROBOTest leverages advanced machine learning, ML, for bug search. However, ROBOTest doesn't use deep learning. There are several reasons for this. One reason is that many testers need an explainable AI technology in order to get test certification of their products. If you're an automotive person, you should be thinking about ISO 26262 here. Secondly, ROBOTest leverages high-performance parallel computing, so those data-hungry ML algorithms can get filled up with vital test data. And finally, for automotive applications, ROBOTest leverages the power of modern virtual vehicle simulators. These can run faster than real life. They can be cloned for parallel platforms. We can even simulate dangerous scenarios with no threat to anyone. Before diving into the tool, let's take a look at some ROBOTest output. We used ROBOTest with a commercial V2V telecom equipment manufacturer. The assignment was to test the safety of a new emergency brake product that could harness V2V communication to shorten braking distances. The client wanted to know if their claim was really true. Also, they wanted to know if they could trust their own software. Together with the client, we plugged in their emergency brake into a platooning simulator. That's what we'll watch in this film clip. ROBOTest took two client requirements. That's 1, shorter braking distance, and 2, no one crashes into anyone else or the pedestrian who might have caused the brake scenario. Using its ML-based search capability, ROBOTest generated and executed millions of test cases, looking for those all-important crashes. It turns out crashes are correlated with the distances between vehicles. So ROBOTest was able to calculate the closest distance at which the trucks could safely brake. That's important for everyone, because while emergency brake saves lives, close driving saves fuel and therefore money, CO2 emissions, and even the climate. Let's watch this film. In the upper left, you'll see a test case box, which shows the test case being executed. This actually models the lead driver actions of accelerate or brake. Does this test case lead to a crash or not? Well, let's watch. The platoon right now is in a high-speed cruising mode. It's coming around a bend. In the lower picture, we can see Roboman, our experimental test dummy. He's not yet visible to the lead driver. In a few seconds they'll come round the bend. There we have eye contact between Roboman and the lead driver. Roboman steps onto the road. This causes the emergency brake to be activated and the platoon comes to a safe stop. So this time he survives, but if we shorten the vehicle distances, he might not. The ROBOTest architecture is built out of some key components in a data flow architecture. At the top we see the system under test, which is a black box. We can read and write to this black box if we know its API. ROBOTest is an inner loop where a machine learning algorithm reverse engineers a model of the system under test. This is done by active machine learning, which generates test cases as system under test queries, fires them into the SUT, and observes the result. The model we get from this is a state machine model, so it not only describes data, but also timing properties. Then, at regular intervals, the reverse-engineered model is sent to a static analyzer known as a model checker. This tool actively searches for bugs in the model. A bug has to break a specific user requirement, so the model checker also works with a list of user requirements. Finally, when a bug is found, ROBOTest confirms the bug by running it through the SUT and observing its actual behavior. This eliminates false bug reports. It's useful at this point to see a tool demo. Here I'm going to show you a short film clip of testing a brake-by-wire application. The first step is to load a configuration file, which contains the parameters of the test job, into the tool. So I go out into my workspace and find the configuration file. This configuration file contains various information about the job. One thing that's important is the test requirement. This is modeled as a piece of temporal logic here. It says if the brake pedal is currently activated and the motion of the vehicle is currently moving, and the slippage sensor on the rear right wheel shows that it's slipping. Then in the very next time step, the ABS component on the rear right wheel should be zeroed. That's to allow the rear right wheel to regain traction on the road and improve the efficiency of braking. We've loaded that. We just have to start testing, and in the right-hand window, in the results table, you can actually see the model growing in size. The first model is 54 states. When we finish execution, after 25 rounds, the current model will be 94 states. So testing is finished, and I can go and inspect every failed test case to find out what input sequence led this brake-by-wire into a bad state. The ROBOTest tool is particularly relevant for testing real-time embedded automotive software applications. These can be anything from Level 3 ADAS applications, such as the brake-by-wire application we just saw, all the way up to fully autonomous Level 5 applications. As we have seen, ROBOTest can even test systems of systems, such as multi-vehicle truck platoons. A key objective is to accelerate your quality assurance by software-in-the-loop testing. ROBOTest offers fully autonomous test content generation, black box testing that scales from one ECU up to many, improved software quality at reduced project cost, optimization for testing complex and safety-critical real-time systems, and finally, integration with existing test automation tools and simulation environments. So why should you trust ROBOTest? Well, it's made from some tried and tested and very well understood components. The model checker we use has been extensively tested by NASA using over 70,000 test cases. It was the only model checker that passed all their tests. The AI learning algorithms we use have been around in the academic community for over 30 years. They are very well understood. Finally, if that's not enough, as a customer, you can always self-certify every test session, because ROBOTest models are built using explainable AI. So every test step can be traced back to your own SUT code. What you get is really what you see. There's no hidden magic. In summary, ROBOTest allows developers to deliver highly reliable software to market quickly through highly automated autonomous testing. ROBOTest is a trustworthy solution to autonomous testing as it relies on both certified and customer certifiable test results based on explainable AI. So while manual testing is a bottleneck or a brake on the quality assurance process, autonomous testing brings QA into turbo. Thank you for watching. Please come back soon to see more videos about ROBOTest and autonomous software testing.